Welcome to the video on chemical bonding. Chemical bonding is a process by which two or more atoms are held together. They combine and they're held together. The chemical bond is the linkage between the two atoms, and it involves either an exchange and or a sharing of valence electrons. The goal of every atom in making a molecule is to get a complete valence shell, 8 electrons in most cases, 2 in some cases. They want to be just like the noble gases because that is the lowest energy state. And so they always want to get to the lowest energy state. Most atoms adopt one of the 3 simple strategies to achieve filling the shell. They either give away electrons, they accept electrons, or they share electrons. Which brings us to the 3 types of bonds. When we have a transfer or a giving and taking of electrons, that is called ionic bonding, and that typically happens with a metal and a nonmetal. So remember, this is the metal is below the step and the nonmetals are above the step. When we have a sharing of electrons, then that is called covalent bonding, and that is going to typically happen between 2 elements that are both above the step. And if we have a metal with a metal, that is called electron pooling, and that's called metallic bonding. We don't really have to do so much with that in this course, but that would be a metal with a metal, 2 things below the step. Ionic bonds are the bonds that are formed when we transfer electrons. So we have one atom that becomes positively charged and one atom that becomes negatively charged because of the way that they want to have the full octet. And then we have this attractive force that happens between those 2 oppositely charged ions. So very typically, we're going to see ionic bonds between the alkali and the alkali earth metals, which are going to be groups 1 and 2 on the periodic table. Those are going to become positive ions because they give up electrons. Remember, they have low ionization energy. They want to be positive charged because once they're positively charged, they have the electron configuration of the noble gas before it. Those positively charged cation atoms are going to bond with the halogens and the chalcogens, which are in groups 6 and 7. Both of those groups want to gain electrons. They want to become negatively charged. Remember, they have a very high electron affinity. So if we have our group 1 atom that loses 1 electron to be positively charged, that bonds with this group 7 element because that has become negatively charged. So the chlorine is negative because it has 8 now around it, and the sodium is positive because it now has 8 around it. These both have their valence shell filled, and now they are negatively charged in this case, positively charged in this case, and they're going to be attracted to each other to make Na plus Cl minus or simply NaCl. That's an ionic bond. Covalent bonds are sharing electrons. So if fluorine in group 7 comes in with 7 electrons, and a second fluorine, group 7, comes in with 7 electrons, they both want an extra one. But if they are forming a bond themselves, what can happen is this fluorine atom can share that electron, and this fluorine atom can share that electron. And so if you put the 2 together, we end up with both of the fluorines having 8 around it. You see inside the 2 circles, they both have 8 around it. So they are both happy. They both have the electron configuration of a noble gas. In this case, however, they are sharing these 2 electrons right here. The way that we draw that is with a line. A line like that indicates 2 electrons between the 2 fluorines. The same can happen with hydrogen. Hydrogen is in group 1, so it brings 1 electron. Same with this hydrogen. They each bring 1 electron. They both want 2. It makes perfect sense that they share those electrons. And so this is what it would look like. Those are shared. And then again, here is how the bond is represented with a dash. So this is covalent bonds or sharing. Quick little conversation about bond energy. I want you to know that whenever we make or break a covalent bond, energy is either given off or taken in. If we break a covalent bond, we have to put energy in. We have to heat up the reaction typically to make a bond break. So we need to put energy into the system to break a bond. And alternatively, creating a covalent bond releases energy. So whenever we form a bond, that is going to be energy given off into the environment. So if we look at a couple examples of bonds, in the top example, we have Cl2. That's one of our diatomic molecules that has a single bond. This dash right here means that there's 2 electrons between those 2 chlorines that are being shared, so they each have 8. The bond length here is 199 picometers. Picometers, we've learned that in the metric conversion. And the bond energy here is 245 kilojoules per mole. So if we look at our second example, we have O2, which is also a diatomic molecule, O2. In this case, we have 2 bonds, which means actually there are 4 electrons being shared between those 2 oxygens. You can see that this bond length is shorter than our single bond, and it also has higher energy, which would make sense. The double bond, or the bond order of 2, makes a shorter bond and a stronger bond. If we move to nitrogen, which is a triple bond. It's also a diatomic, but we have a triple bond here. This one has 3 bonds, and each one of those bonds is 2 electrons. In this case, there are 6 electrons shared between those 2 nitrogen atoms, and they still each have 8. And if we look, our bond length is 110, so our bond length is even smaller than that of the double bond, and our bond energy goes up as well. So as our bond order increases, again, the bond length decreases and the bond energy increases. So 3 ways to describe this table is as the bond length decreases, our bond energy increases. Next, as bond order increases, this is first order, this is second order, and this is third order. So as bond order increases, bond length decreases. And finally, as bond order increases, bond energy increases. So as we go from single to double to triple bonds, the bond length decreases, so the bonds get shorter, and the bond energy increases. So those are stronger, tighter bonds. And it makes sense, if it's a stronger, tighter bond, it'll be shorter. So a quick recap, ionic versus covalent. Ionic bonds are typically a metal with a nonmetal, and they transfer electrons. Please note that these also completely dissociate in water, and they conduct electricity. For covalent molecules, we typically have 2 nonmetals, so 2 things above the step. They are sharing electrons. They do not dissociate in water, and they do not conduct electricity. There you have it, an introduction to chemical bonding. Good luck.